Ka-chow. All right. Well, yeah. I'm gonna share my screen. I already got it recording. All right. Hey, Kelly.
Hey, how's it going?
It is going on bright. We got pretty far yesterday with these stairs. We had to keep going back and forth, like we were reusing or going back and forth and using like the there's a link in the group chat for that model that the metal vendor provided for the staircase. So we had to keep going back and forth into that stair model yesterday. And so it was really helpful anyway to have a model versus just the drawings. But yeah, we got pretty far. Today, what I want to focus on with you guys is I think at the end we're gonna actually make this planter like a real planter. Right now it's just a solid block that literally has no framing or anything in it. It's just a solid piece of material that's sitting there at the floor. But today, the main focus for what we're trying to do today is there's going to be handrails that go all the way up the stairs, and I want to try to do our best to knock those out today. So won't take very long once we get the first set started, but we got to get through that one first, and then the rest of it should be smooth sailing from there. And then we can tackle that planter too. Maybe be able to get this thing plotted today, depending on how things go. Yesterday we cut it, I think, an hour too early, just because I was starting to lose my voice a little bit. I didn't want to come into work today and not be able to do anything with you guys. So we all got to the point where we were done with modeling the treads, modeling the stringers underneath those treads, and then we were like, oh, okay, we'll just. Oh yeah, you're good. Then we just went ahead and we got to that point and just called it from there. So before we jump in, I pull up go back to here. I am going to pull up the model link they had sent over. Where the heck was that? It was from Greg. And it was a little further down. Oh, that's HNTV anyway. That's not this. I might have archived that email as we were almost done with it. I had to go find it. Bradley Law. Stair drawings and stair model should be in here somewhere. Right there. This was super cool. If you guys had a chance to play around with it at all. I mean, the one thing that I have to complain about is that the zoom is like inverted from what you're used to seeing in AutoCAD. I don't know if there's a way to change that, but it kept getting me every time. The reverse mouse zoom direction. That's what I was looking for yesterday. That's much better. So zooming towards the object zooms in, zooming out now it zooms out. Yesterday, it was the opposite. When I was in here, and every time I'd zoom in, I'd be zooming out, and then vice versa too. It was kind of annoying. I'm like, every time I'd try to get close to a part, I'd mess it up. Anyways, so yeah, so today our focus is going to be these guys. Yeah, we're going to get those drawn in. And these little steel cables that run in between those posts too, but we'll do the post first and then worry about the steel cables following that. All right, cool. Now again, not even our scope, but these do bolt into our treads. So we do want to make sure that we show them because we do need to kind of show those locations of where they're bolting into the tread. So that's why they're important to show. Otherwise, they really have no other we have no other scope tied to them except for the fact that they just interact with what we're building. So before we get moving, I'm going to make sure I clock into this staircase. And you guys, if you're following along, you can clock into indirect and just say you're doing stair training. I'm going to clock into the actual packet. That way we're not triple billing it though. Imagine from the project manager side, if they saw like 3 people working on it at the same time, they'd be like, what the heck? Yeah. So I'm going to start there. Once we do that, once we do that, and get a head start on what we're doing here. So we go back to the job folder, and I'm going to pull up the metal shop drawings for the staircase as well. Should be this guy here. Also, I think those are also in that group chat from the other day. I think it was like Friday when we started this thing. So I'm going to pull those up so we can take a look at what we're dealing with here. Oh, you know what? It's not this drawing. It's actually this one. It was one of these two. Yeah, it was this one. All right. So again, these are the steel shop drawings. We're kind of working based off of what they have provided because, again, architects do draw stairs, but a lot of times they'll draw them and they won't be 100% spot on to what is actually going to get built. They're more of like a conceptual design versus like if we're dealing with the metal shop drawing, you know that it's going to be a lot closer to what reality is going to be out in the field. So anytime we do these stairs, it's always preferred to work off of the steel shop drawings if possible. If they can provide a model, that's even better, especially if it's one you can bring into AutoCAD, but a lot of times they don't have that. They'll just provide a 2D shop drawing like this. And usually there's enough information to go off of with this, but there may be some questions that we might have to ask the PM if we only had this and we couldn't see exactly everything we needed to see. But I usually try to do my best to request that from the PM, and the PM will request it from the contractor at the beginning of the job before we even start drawing it, because there's a lot of things that benefit us as drafters by having access to the metal shop drawing. So what's really funny about this one particularly is that they actually have all the steel installed in the field already, according to what Greg has told me. So they're just kind of waiting on us now at this point, which is goofy, but I think we got awarded on this job a little bit late. So as we're looking at these vertical posts, jump into here, you can see that these posts are being called out as 1.5 by 1.5 by 3/16 inch thick square tube. And then these guys here, the cables that run between, they're calling those out to be 3/16 diameter stainless steel cable. I don't really care too much about the rest of those notes, although like if we wanted to go crazy and show those extra things, we could, but I'm not going to worry about that. For the purpose of our model, the main reason we're showing it is to show these base plates and where they're interacting with the tread. So, so for us to put these in there is kind of overkill. Not to say it would be wrong, it just takes more time and it doesn't actually benefit us here. So I'm going to leave those little tensioners off, but we'll show the cabling to show that it does exist out there in the field. You're also going to see that there's a handrail that's right here. It is called out as a 2 by 1 by 1/8 inch thick wall piece of steel tube, and it just kind of waterfalls right down to the floor. They kind of give you a dimension here for how far from the last tread to the end of, or the center of the handrail is, and that's pretty standard. I've seen that a lot of times on stairs where that actually goes 1 foot past the stairs and then it stops. So I think that's probably an OSHA standard there, if I was to guess. I'd have to look it up to confirm that, but I think that probably is the case. You look at this guy up here, this is the top of the stairs, and you can see those tensioners shown as little black dots there. I bet you if I turned off my line weights, yeah, you could actually see more detail as to what they look like, but really it's kind of just like a washer and a bracket that holds that cable like this. But again, we're not going to go the extra mile on that part, and we're just going to leave that part off, but we'll show essentially what this looks like here for the steel cables and the steel posts for the handrail and guardrail. So let's go ahead and draw one of these in. See if I can find the height. Height's also going to be super important, and I got to talk to you guys about one little thing on that too. When dealing with a handrail or a guardrail, here they tell you here that this handrail is exactly 3 feet from the finished floor to the top of that handrail. And Why that's important is a lot like the stair tread. As you're working on stairs and you have to make sure that they all have the same distance and height from one tread to the next, this handrail also has to match that same angle or slope of that staircase too. And how they usually do this, industry standard for staircases, is that is going to be 3 feet from the front nose of your stair or your tread. So if I actually did pull a measurement here going straight up to that handrail, it should read 3 feet here. I'll check it and make sure, but it, if they did their homework, that's what it should be, right? We'll check and see. We're gonna do some product testing here. All right. Yes, 3 feet. The reason they measure it from there is because then it's consistent all the way up. Because technically this would be like your finished floor on your top tread. So as you get to here, that's your 3 foot mark. So you want to measure 3 feet up from there to the top of that handrail, and that should be 3 feet from there to the floor. They don't usually measure it from anywhere else on the tread. Like if you were to pull it from the back of the tread, it's going to obviously be like a lot taller than 3 feet. It'll be 3'7" and 3/16. So like the reason is they do measure from the front to keep that consistent. So whenever you're dealing with a handrail, it's something to keep in mind, that slope is determined based on the front corner of each tread. So 3 feet it is. Okay. The other thing we need to know too is we need to take a look at our section view, which is going to actually provide those heights anyway, as well, but it also gives you more of a description of what we're seeing here. So again, there's your 1.5" by 1.5" by 3/16 thick square tube steel, your vertical post. At the very top, they call this out to be a 5/8 by 2" flat steel. That's just the guardrail cap at the top. And then you have your handrail here, which is a 2 by 1 by 1/8" thick rectangular steel tube. There are brackets here too, which we can look those up and see what they look like. I bet it's probably just a pre-manufactured bracket. Sometimes they will be, sometimes they'll be a custom made one, but this one does have a product number on it. So if I look it up, I'm willing to bet it's probably something that you can buy online, and it is. It's a product from a company called CRL or CR Lawrence. They make a lot of glass manufacturing products, like, or glass door products and glass hardware. I always joke around with the doors that are over by like Sam's office, and I don't know if Doreen's over there, but those offices that are new with the glass doors, they all have CR Lawrence hardware for the door, and I think for the track on the glass too. Now, Keith's office over here also has CR Lawrence. You can actually see it on the back of his door at the bottom there. It's a CRL on it. It's just a very common company that produces like glass hardware. So, so it doesn't surprise me that they're also making brackets for stairs too, because a lot of times you'll see stuff like that. All it is a threaded standoff though, meaning that it's just a piece of cylindrical tube that comes off of that bracket or that post, and it's going to be threaded so that way they can just bolt it right into that that vertical post. And then you can see under here, it's got like a little flange that's made to hold the handrail. A lot of times you'll see a wooden handrail on a staircase, but in this case, it looks like they actually are using a metal one based on this. I'm not even sure that that bracket's really going to work with a rectangular tube steel. I mean, it's not our scope, so it's really nothing we got to worry about. But the way that they have it shown on the CR Lawrence website, this does have a little bit of a curvature to it. So I wonder if they have a flat attachment piece or if it's only provided in curved pieces, because that could be something that might be problematic for them. Anyways, we won't go there. It's really not our not really our issue, because it's something that has to do with the steel only. But it's something I just noticed and I wanted to mention it, because I'm like, yeah, it doesn't seem like that would really work very well. All right. Okie dokie. All right, let's go ahead and go back to our model. I'll split screen our model with the drawing that we've provided, or we've been provided with here. And we're going to kind of use this in tandem with our drawing to get this drawn in. So I'm going to work off to the side to start with. Save it here, even though I didn't make any changes yet. But we're going to start with drawing our vertical post. And that is just simply 1.5 by 1.5 inches. And so what I'm going to do is take a rectangle and draw it 1.5, tab 1.5, represent the footprint of that vertical piece. Let's see. I do think we want to make it a little bit taller. Looks like you can actually make it at the correct height if you really wanted to, but I know that the top of it's going to be angled as well. So we're going to have to be careful about that. So I might make it a little taller than what it needs to be for right now. I might just set it at 4 feet. That way we're like 6 inches, we're 5.5 inches higher than what we need to be. But we'll come back and we'll slice it when we need to. So I just press pulled that rectangle up 48 inches here to create this vertical post. One other thing that I'm going to do too is I'm going to use that shell command that we had used the other day. That is in your solid editing toolbars. And if you go up to solid in there, or 3D modeling toolbars and then solid editing. So you go up here to solid, and then over to the right, there's this chunk of solid editing commands, and the shell command lives right there. It will hollow out that part for you. So if you click on that, select the part you want to hollow out, and then it's going to ask you, do you want to remove any faces? Meaning that if you're drawing like a tube, you want to click on the 2 ends of that tube. So that way you can show it hollowed out just like that. Once you're done selecting your faces, you hit enter. And then you can go ahead and tell it how thick the walls of that tube need to be. And looking back at our drawing, it looks like 3/16 is the number that we need. So we're going to go 3/16, enter, and we're going to close out of that. So there is the first tube that we're dealing with here. I'll leave it on the ribs layer for now because it's a little easier to see. Once we've got it completely done, I'll put it on that by others layer like the rest of our steel. And that way it all matches the same color scheme. And if you needed to, you could like isolate just the by others layer to show only the steel. Anyways, so let's see. Let's not worry about the top part just yet. We're going to go down here at the bottom of this and we're going to figure out what we're doing here with this flange. And then there's a plate that sits there below that flange too. The flange is like a decorative piece that just sits right atop of that plate just to cover the bolts so you don't have to look at them. And it's going to make it look kind of just like a finished piece or like a finished end on our cabinets would be. It just kind of resembles something like this. If you were to take that flange off, which you can do on this model, you can actually see that plate. And that's what they're trying to avoid, is being able to see all of that mechanically fastened, like all the screws and bolts. They just want to see something that looks nice and finished. So that's kind of what we're going to go on, move on to next. Whoops, goodness. Okay, so going back to our drawing here. I'm going to see if they have a better detail of that flange, because right now it just says it's a 14 gauge carbon steel base flange. So if you're trying to find out what the heck is 14 gauge, because I'm not a mechanical drafter by any means, you can Google it. Usually what you'll want to do is to type in 14 gauge steel, and you can pull up a like usually there's a decimal conversion for that, but there's usually charts on here too that you can use as well that will tell you what those different gauges mean. So it looks like the thickness of the metal is going to be 0.075, so just a little over a 1/16 of an inch. All right. We do need to find out what that flange dimensions, what the flange dimensions are going to be. And so I'm going to quickly scan over our drawing to see if they've provided any other details that might actually give us that information. Actually, right here, this is perfect. So this is a pretty decent detail showing the bottom of the handrail. And plate as well as the cap or the flange that goes over it. So these would be dimensions. This would be your flange from the top down. They made it so you can see the bolt heads through there, even though they would be covered. We still got to figure out that plate that sits below, and it looks like they actually have it here too, which is great. One thing I'm just trying to figure out is like, what the heck they did that for? Very strange. This says 5 1/4. This says 5 1/8. So we're gonna have to pick one and just run with it. I probably will just go 5 1/4 for that to make sure there's enough room in there for that plate to live inside of that. I mean, you could make it the 5 1/8. I'm sure it would be fine too, but we're not going to dimension any of this on our drawing anyway. It's mostly we need to know where the bolt locations are going to be. So that's the big important thing. All right. So let's draw in the plate next, and then we'll worry about that flange. So the plate, I'm just going to simply use the box here in AutoCAD 3D Tools. I'm going to draw that in off to the side. We're going to draw it in at, looks like 5 inches by 5 inches. So 5 by 5 with a thickness of 3/8, so 0.375. Okay, and let's put the bolt holes in there too. They actually give us the information for that. It looks like they are 9/16 diameter. There's going to be 4 of them, and they are held a 1/2 inch back from either edge of our plate. So let's go in the cylinder here. And we need to set this to diameter. Okay, and then once we've done that, let's go 9/16. And we'll just make it some arbitrary height. Let's make it 8 inches in our case here. What I'll do with that then is I'm going to use the move command. I'm going to highlight that part, selecting the center point of that cylinder. I'm going to drop it right on the corner. From there, I'm going to use the move command 2 more times. One to set the Y direction and one to set the X direction here. So we can go 0.5 this way, 0.5 that way. All right, and then I guess I got to move it one more time so that way it's intersecting the actual part, because we're going to use the subtract command to remove that from the plate. From there, you can use either mirror or 3D mirror, and we're going to mirror these parts around so that way we have 4 posts, 4 holes that'll be in here. And then we're going to use the subtract command next. We're going to highlight our plate, and then we're going to highlight our post. Should give us the exact copy of what we're seeing here, right? And then the last thing we got to do, we got to mount this plate to the bottom of our handrail. So because I'm dealing with a square, I don't necessarily have a center point to use. So what I'm going to do is use the mid between 2 points, holding down shift and right clicking my mouse to get to that. We're going to go mid between 2 points. We're going to go from that corner to that corner. Then we're going to hold down shift and right click again and go mid between 2 points from that corner to that corner. So right now that tube is intersecting that plate. Eventually what I'm going to do here is I'm either going to slice that off. Well, I guess what I can probably just do is lower this down, because I left that top taller than it needs to be intentionally, so that way we can chop it down later. All right, so we got the plate, we've got the post. We do need to put that flange on there too to show the decorative flange. And what we're going to do is we're going to make that 5 1/4 by 5 1/4 by 0.075 for that 14 gauge thickness. Drop that in on here, 0.075. That's what that would be. Okay. And I may not show it completely the same way they do. They have it, what they're doing here is they're actually laser cutting this out, most likely with a CNC. And they're probably going to do this, then bend that part so that way it creates a flange. But what you would see is like by the time you're done with that, of course, like their model does show that too, is you kind of have like these weird little goofiness, at the corners, which I mean, that is what it's going to look like, to be honest, but I'm just going to draw it as a standard flange for our case because we're not making that, so we don't need to worry too much about that. All right, so to draw that flange, you could go about it several different ways. The way that I'm going to tackle it today is I'm going to take a box in AutoCAD off to the side again, and I'm going to go 5.25 to match the side here. Then I'll hit my tab key, and I'm going to set my other distance to 5.25 as well, 5.25. Oh, hold on a minute, I messed something up. 5.25, 5.25. Okay, that's better. And then the height is 1 inch tall. So 1 inch here, boom. All right. So they don't tell you what that radius is on there. Oh, wait, maybe they do. Radius of 1/16. Okay, cool. Never mind. They do have it there. It's just noted in a weird spot. So there is a slight radius to the corners. And what we're going to do is we're going to use our, let's see, fillet edge command. So we have talked about chamfer edge quite a bit. We've used that for mitering parts. There's also a command called fillet edge as well. And you might already know what that really does. It's just like fillet when you're dealing with fillet in 2D. This is like your 3D version of that command. Fillet edge will allow you to select the edge of a part, set the radius, and then have AutoCAD automatically run that radius through it. So we're going to do that here. We're going to go down to here once we're in the command, and we're going to select radius, and we're going to set it to 1/16 or 0.0625. And then we're going to select each corner or each edge that we are intentionally making a filleted edge. So that would be all these outside ones, except for the bottom. So going around, highlighting all these. Once we're done, hit enter a couple times, and we should be left with that. Okay, and then once we have that, we can go ahead and use that shell command that we've been using for the tubes, and we can actually hollow this out to match the correct thickness of 0.075 here for that steel. So we'll use shell, highlight our part, and we're going to remove the bottom face there. We're going to hit enter and set our offset distance, which should be the thickness, to 0.075. I know we don't have the goofy corners like they have, but this is pretty on the money when it comes to showing like what that flange is going to look like. Or they call it an echelon cover. I mean, it's just a cover that goes over it though. So you can call it a flange, a cover, whatever you want to refer to it as, but really the purpose is just to cover up the bolt that we're going to be hiding under there. Okay, so like what we did before, we're going to use that move command to get this lined up, highlight that part, hold down shift and right click my mouse. I go mid between 2 points to get the center of this part. So I'm going to click this corner. I'm going to click this corner here too. Now that I have that, we are going to mid between 2 points, that corner and this corner, which should leave us with a flange atop of our plate. So you can kind of see it if you go into 2D wireframe here. There we go. Or if you go into X-ray mode, you can see it that way too. Kind of see what's going on. All right. And then I guess the last thing we want to do too is we are going to actually, I'll put it back on conceptual. I think that's what we had it on. This plate does have a hole in the center of it, and that is to run this tube straight through. So we're going to puncture that hole next. So what we need to do is we need to make a solid object that matches this tube, one that's not hollowed out for this purpose. So what we're going to do is use the box command again, go from this corner to this corner, and we're going to go straight down. The height doesn't really matter to us because we're only using it to subtract from the flange. So we're going to use the subtract command, select the flange, enter, select our tube that we just drew, hit enter. And now if I just isolate that part, you can see that I have that hole punctured through it. Okay, so that takes care of the vertical tube. It's pretty cool. We do need to go back. I want to check something here. If there's actually one of these brackets at every location, or if there's, maybe there is every other one. Depends on where you're looking, I guess. Most of them have a bracket, some of them don't. I'm not going to worry too much about that right now. But what I want to do next is get all of these put on the correct layer. And then I want to take these and I want to get them lined up to where they need to be. So I can either, I think what's going to be the best way to go about this, I might turn this into a block temporarily. I'm going to have to edit it later, so I can't keep it in a block forever. But I need to call this my vertical posts. And what I'm going to do is pick a base point that makes sense. So what I'm going to do is use the center of this as my base point. So I'll hold down Shift, right click, get that mid between 2 points icon to show up, and we're going to go from there to there. So the center of that bottom plate is going to be where our grip is for moving this block around. And then I'm going to select objects here just so I can select all the parts that pertain to this post. All right, once I'm done with that, let's hit OK. And we have a block for that for right now. Said it's going to have to move or change anyway, so I'm not overly concerned about it. But now I have this permanent grip point until I explode the block, where I'm able to quickly grab the center of that quickly grab the center of my post at the bottom where the floor meets the post, and then I'm able to move it to the treads that need to have those posts. So we kind of were looking for drawings for the planter side of the stairs yesterday, but I didn't see any. So because we're starting at the bottom where the planter lives, we're going to go and look at this model. And we're going to try to locate these posts. So it looks like the first official tread does receive a post. We go up 3 treads, so 1, 2, 3. The next tread from there, the third tread up gets a post. 1, 2, 3. The next tread from there gets 1, 1, 2, 3. And then you got, it's like a double post there, which is kind of goofy, but so we're going to use that method of thinking to line these up, starting with that first official tread. The other thing that we need to know too, is we need to know how far away from the edge of that tread this post is meant to be. It doesn't tell you that here. So we're gonna have to look elsewhere to see if they provided that information on a different part of the drawing. It's probably here somewhere. It's probably just buried in the mix of all the extra lines that they have provided. Or it could be in a detail here somewhere. And if it's not here, the one thing that we do have that's benefiting us is that we have that 3D model previewer that we can use to locate the center of this flange to the edge of the tread. Looks like we might have to do that. Like I said, always a good idea to try to figure that out as best you can. If they provide a dimension, you want to try to use it. If they don't provide one, then scaling is going to be usually your next best friend. But we do have this this model here, which is really convenient. So we're going to use this to try to figure out from center of this post or center of this plate to edge of tread what that dimension is. So let's go down here, measure. We'll go from midpoint to edge of tread. Okay, so they have it at 4.1 inches there. Let me check another one and make sure that that matches up too. Ooh, all right. Oh, again, it is pretty difficult to navigate this thing. Okay, so 4.1 seems to be pretty consistent here. I'm looking at that green direction, the Y direction. It says 4.1 is the distance from the center to the edge of the tread. So we'll use that when we go to place these posts. So what I'm actually going to do is use the midpoint of the edge, drop it so it's like directly lined up with the edge of that tread. Actually, I probably need to start here. Sorry, I need to get that lined up. So it is centered in the depth of the tread, and I have the midpoint of that plate centered on the edge of the tread right now. So I need to use the move command and go 4.1 that way. And I can go ahead and copy that up. And I'm going to use a base point that is commonly used between this tread and the next one up that we're using. So 1, 2, 3, post, 1, 2, 3, post, 1, 2, 3, post. Okay. So we've got that first set dropped in. We still got some work to do, of course, because we got to put in the steel cable, put in the top and the handrail, but that's a good place to start. Let's go back here and see where the next post is going to be. Let's see. Where is the top one? We'll start at the top and work our way down. It looks like. So it looks like there's one at the top of that baby tread. And then you go 1, 2, 3 down. 1, 2, 3 down. Ah. Oh my gosh. Trying to get a better view so I can actually see it. All right. 1, 2, 3 down. 1, 2, 3 down. Okay, so it's threes again. That's fine. All right. Going back to our model again. All right. So there's going to be one that sits up here. And then, like we said, we're going to go 1, 2, 3. I'm using that copy command, or you could also use copy base to do this. 1, 2, 3. 1, 2, 3. All right, 1, 2, 3 would be the next one, but I need to switch from using the front of my tread to the back because I don't have a front to snap to down here. So I'm using the back of that to snap to that. Okay, so that should give us the main posts and where they're located. I do remember though, there were some goofy ones that were mixed in as well. So if I go back to the view of what we were seeing here, we are also going to throw, looks like they have one that's pretty much just spaced directly next to this one. Okay, yeah, the plates are even connected. So like really, I guess I can pull a measurement and see if that's, see if that's exactly the same, which would be, come on. Oh, come on. It's about 8.5 inches that way. And the depth should be the same, but we'll check it anyway. 5 inches that way. Okay. So these ones have a unique plate. I have to be careful about that. I'm gonna write this down. That way I don't forget. These plates are 5 by 8.5. Five inches on the short side, 8.5 on the long side. And they have a total of 3 bolts on either side. Okay. Cool. I just did me a little napkin sketch, which apparently you can't see because my camera's not on. Wow. All right. There it is right there. It's probably mirrored because that's how Teams works, I guess. But we're going to use something like that.
It's at least
So,
not backwards, so I can read the numbers.
oh, it's not backwards. Okay,
No.
cool. Cool. I had made a little napkin sketch so that way I could get, I don't have to keep going back to this model. I was getting kind of flustered with the model yesterday because I didn't realize you could uninvert the zoom command on it. But yeah, I was struggling pretty bad yesterday because I kept zooming in when I was supposed to be zooming out, and again, vice versa. Just getting some ice real quick. All right, cool. We're conveniently like placed right next to the break room because that was the only space they had.
Kind of awesome.
Yeah,
I always feel like I'm a very disruptive member of the team when I go up to get my water refilled 80,000 times a day.
that was the best part about sitting where Jake Stalker sits because that was my
Yeah,
first desk when we moved out to that part of the office. And I loved that desk. It was perfect because you could get up and go right back to your desk if you had to use the bathroom or use the
yeah,
break
like
room or go to the
minimal
fridge.
disruption.
Mm-hmm. Exactly.
I feel like
It
an
was,
elephant tromping over all the different hollow floor panels by every single desk on the way over there.
yeah. Unfortunately, here we don't have hollow floors, but I know how that is.
Yeah.
I know how that is because up there used to be a project manager up there that was very heavy-footed. Um, and it was nothing to do with anything like they it was just like they stopped when they walked and they had
Funny.
a
I
bad
try
habit
not
of it.
to, but yeah, I've had to adjust the way I walk because at first I didn't realize like what is making that noise, and then the more I
Hmm.
did it, the more I was like, oh, it's me making that noise.
Yeah. And at one point, I don't remember who it was, but one of the trainees had asked me, they were like, does that guy always stomp his feet when he walks, or does that guy always walk so loud? And I'm like, yeah, unfortunately. Uh, anyway, that guy doesn't even work here anymore, so it's kind of like just goofiness, but let's see. Let's see. I am going to explode these. Actually, before I do that, let me make the middle post because there is one that sits directly center of these two. And go from there to there. Okay. And then we'll explode these because these ones we need to modify to adjust that plate. So I guess we got to delete that anyway because we're going to have to make a new one. All right. So based on the napkin sketch, we're going from a 5-inch wide plate to an 8.5. So we need to grow this. Let's see. We need to grow this here. Yep, 3.5. It's not that early. I can still do some math. I almost did it on my calculator. I want to be honest with you, just to check and make sure I wasn't just getting sleepy and goofing it up. I'm using the midpoint of that to copy this, to use the mirror command to make a copy of that post, so that way it's centered in the same depth as what this one's centered in. But I've still got to add in the third set of bolt holes, and so what I need to do is I can kind of just fill these in like this. Use the copy command now to put another one right there. Then what I'm going to do is use the move command using the center point of this bolt and just moving these. Oh, that won't work. Oh, okay, they must not be centered. Okay, hold on. Hold on. We got to do some work here then. Man, it looks like it's going to thunderstorm. It's dark.
Supposed to snow here, I think, for like several days in a row.
Oh, snow?
Yeah, and ice. We have like a winter weather advisory out right now. It's
Oh,
13 degrees out at the moment, so salt's not gonna work.
yeah. I remember those days very well. Oh, all right. All right. We're gonna use I don't know if you guys have played around with this at all, but I'm going to use that 3D stretch command to move these holes to be centered instead of off-centered. So we're going to highlight those and move them just like that, like magic. What were you saying, Cody?
It's going to rain all day today
Oh,
and tomorrow and Thursday.
yeah. That sounds like a blast.
Everything's going to be wet. I don't like it when it's wet.
All right. I just mirrored those over. I'm going to subtract them now. All right. How about that? Got our plate all done on place, so unhide. All right, cool. Realistically, what I could probably do is end up just deleting that one and then copying this over. Yeah, I'm going to use this point up here to make sure I'm grabbing the same height. I was a little bit nervous about that. So go from there to there. We're going to mirror this tube again using the, you can either use the center point of that circle or the midpoint of your plate. Just like that. Okay, and then we got to make new flanges for these because they are a little different. See if they give us dimensions on them anywhere. If they don't, then what we're going to have to do is use that 3D model they provided to try to figure that out. I'm going to start by looking at this drawing here, view C on 0.5, which looks like it should be a blow-up view of that area. But it doesn't show those. Oh, that's funny. All right. So what we're going to do then in that case is we're going to take their model from SharePoint, or not SharePoint, we're going to take their model here and we're going to try to pull a couple dims off of it so we can get these plates drawn in correctly. So there's our plate, and I need to get the distance. There we go. From this side to, makes it difficult to, there we go, perpendicular to that side. So it looks like 5.3 on the short side. Again, kind of writing that down on my post-it note here. And then the long side, let's go from there, spin it around so we can actually see what we're looking at. I got lost. Where am I? Okay, there we go. 8.8. All right, here we go. So 5.3 and 8.8. Let's go back here and we'll do what we did previously. We'll make this flange off to the side. We're going to go 8.8 on the long side and 5.5 on the short side. Or no, sorry, 5.3 on the short side. Sorry, I misspoke. And 1 inch tall to match the plate that we've already got drawn in from over here. Okay, and then also keeping in mind, we did have that 16th inch radius on there, so we got to go back and use the fillet edge command to apply a 3D fillet edge to our solid object and making sure we're still set to a 16th. Awesome. Just going to go around and highlight all of the edges that I want to be radiused. Just like that. Okay, and then when we're done, what we're going to do is we're going to shell this again using that thickness of 0.075. So going back up to solid, going over to shell, click on our 3D object, click on the face we do not want. There we go, 0.075, just like that. Okay, so we got our base plate here, or flange, whatever you want to call it, little decorative piece. Okay, and we're going to use that move command and we're going to go mid between 2 points, selecting this corner on the inside to this corner on the inside, and then we're going to line that up with the corners of this plate here. So mid between 2 points, this corner and this corner. Oh, come on. There we go. So you got to be kidding me. All right. And then just like last time too, we need to remove the post from that plate or that flange. So I'm drawing in a separate box that is going to be used to subtract it from that flange. I'm going to go back to the flange, start a subtract command, click on that object, hit enter, switch over and select these red pieces we just built. That should give us, those 2 holes through that flange for the post to fit in. All right, so we just got to copy this over to here, and then we can call those done using this point here to paste it to that point there, because it should be lined up just perfectly. All right, cool. All right, I think that is it for the vertical posts. So that's pretty cool. I guess what I'm going to do is actually just do one side of the stairs, and then I'm going to mirror the entire thing over to the opposite side once we got this one all done and cleaned up. Okay, so I guess what I'm going to do next is go back to that section view that showed the handrail. There it was, this guy. And we're going to use that, and we're going to work off of this and building the proper height for this top plate. All right, so that top plate on top of the what's called the guardrail, it's usually the outermost rail or railing. It looks like they want it to be 3'6½", and that's from, again, the front nosing of our stair treads or the finished floor at the top and bottom. So we can actually take that, and a lot of times what I will do when I draw staircases is I'll take a standard, just like a 2D line, I'll snap it to the front corner of the tread, and I will draw it at the height that it needs to be. Second. Okay, sorry, I thought I messed something up. All right, so I'm going to take a line from the front corner of that tread up to 3'6½". Okay, don't die over there. 42.5.
I make no promises on that.
All right. What we'll be doing here is we're just taking that line and we're simply copying it down throughout our treads. One cool thing you can do as well, honestly, I'm going to do it this way so that way you can see how this is really beneficial as to why we block those treads. If we did block every single tread into a single block, what you can do is rather than drawing that line in here, you could actually double click on your tread block, go ahead and hit OK, it'll open it in the block editor. And as long as you know which side is the front, which hopefully I'm grabbing the right side, I think I am. I'm going to go to visualize and switch this to be a 3D view. If I can find those, there we go. Put a conceptual here. So right now I'm looking at the tread in the block editor. So this is just a single tread in that block. And if I wanted to, I could take that line we were about to draw. I can go straight from that corner up the 42.5 inches or 3'6½". All right. I can hit OK and close the block editor. I'm just putting that line there temporarily, but what it will do is it will paste it on every single tread for us. So that's kind of one of the important things as to why we like to do the blocks for the treads like that, because it makes things like that a lot easier and faster. You can also do that here too for the baby treads. I'm just going to call them that because I don't know what else to really call those things. So we're going to go over to visualize again in the block editor. And we're going to switch this over to conceptual so you can see the actual tread. So this would be the front side over here. And again, this is going to be 42.5 inches tall. You can go ahead and save changes to that block. And then it should provide us with a line for that one and this other baby tread here since they're blocked together. Could also do that for the landings too, but we had to make these separate blocks because they're two different lengths. So really, I'm just going to draw those in my model space here. No block editor required for this one. 42.5. And 42.5. Okay. I'm only doing it on the right-hand side of these stairs as we're going up because again, I'm going to mirror everything once we're done. But the reason I'm putting these in here is because when we go to draw in the handrail, it's going to make things a lot easier to be able to see what the actual height should be for the top of this plate up here. So that plate needs to be at the same height at the front of each nosing and as it goes down the stairs. I just realized I don't have a plate and a post here at the floor, so I'm going to add one in here as well. No big deal, but I think it should be the same as these. So again, just like before, it looked like it was 1, 2, 3 down. And because I don't have a tread here at the floor, I can't necessarily use this point like I've been doing to snap it to there because there's no point to snap to. But what I can do is I can use the base point of the tread before it right there, which will allow me to snap it there. And it should be in line with the floor, like just like that. So that actually does work. I just gotta play around with your base points. And I kind of learned that from an old guy that I used to work for a little bit, the old commercial roofer. And he was, I was there to teach him AutoCAD, but he taught me a couple of things like that. So I was like, hey, that's cool that you can use your base points and for your advantage. It's kind of like playing a game of chess. You have to think 2 steps ahead in that case. But like if you know that you have nothing to snap to, if you have something that lines up with it elsewhere, you can use that to move your object. So that's what I did there. And now from that point, we can draw in the top cap, which again, they're calling that to be 5/8 thick by 2 inch wide. So let's just draw a box off to the side for right now. That is, we'll make it 200 inches long, and it's going to be 2 inches wide and 5/8 thick. All right. Here we go. Let's put that on the by others layer too, because I'm just going to use that to line everything up. Okay, and let's see. Now is actually a good point where you can make a copy of this. I'm going to use the align command. And I'm going to use the align command using that corner, that endpoint there. I'm going to snap it to this red line, the top of that red line, and I'm going to do the opposite. So the bottom corner of this side, I'm going to snap it to the top of any of these red lines. Could be any of them. And so right now that should be, wait, did I do that right? Hold on a minute. Let me make sure. I did not. Oh. I should have stopped me. There we go. I had to move it because that is measuring to the top and I accidentally put it at the bottom. So I was measuring to the bottom at 3'6.5", but that needs to be to the very top of this handrail or guardrail cap. So
yeah, that's the handrail, right?
This is I'm going to call it the top cap to keep it from being confused, but it's this piece that sits above the vertical post. The actual handrail would be this guy here, and that's what people will actually be using as they walk up the stairs if they're going to use that railing to hold on to.
I was gonna say the way you were positioned it kind of looked like it was gonna be the handrail. I was like, wait a minute, it's on the outside. Does he know it's on the outside? But,
Yeah, I gotta move it still like inward a little bit more. So, good observation. It does need to be moved in, but I was just trying to line it up with those red lines to see how tall it needs to be. So I'm starting with that, and then we'll be using a combination of like the slice command and a few other commands to get everything to be lined up just right. And as I was talking there, I just used that grip point on that block or box to extend it out. So that way it sticks out a little bit further past where we need it to. Because like I said, we are going to slice it. And just like we did with that pedestal that you guys are practicing with, we're extending it past where we need it to be. So that way we can chop off any excess that we don't need. And we don't have to worry about having like a corner that's a little bit too short, and then we got to try to fix it and worry about that. So anytime I know I'm going to have to slice something, I'm going to extend it well beyond where I know it needs to be sliced at. So like right now, this is kind of a ridiculous amount of overhang, but it's going to be fine because we're going to chop it off here shortly. All right, so I need to move this in. Like we had talked about, I do need to slide this in so that way it's centered over these vertical posts. Because if I looked at it here, if I isolate these parts, look at it from the top down, you can clearly see that it's not. There's your post there, there's your rail. So it does need to shift this way a little bit. And so for us to be able to do that, I can use the distance command to get a actual accurate dimension on how far it needs to move. I'm just going to use the center of the bottom of my handrail, and I'm going to use the center of the vertical post. Then what I'm going to pay attention to here is what that Y direction is, that green direction you see on that gizmo down there, which I think that actually is the real term. It looks like 3.1 is the distance that's going to make that centered. So we're going to move this 3.1 in the Y direction towards the staircase, just like that. I can go ahead and unhide what we have currently drawn. And what I need to do from here is I need to play kind of a game of connect the dots because we're going to continue this handrail down. And I can either work on this next part of it, or I can work on the flat part because there will be a flat portion that sits right in the middle at the landing. A lot of times the stairs that will actually follow the rise and the run of the staircase. So if the staircase flattens out like in a landing, that handrail typically will flatten out too. Or sorry, the guardrail. There are times where it doesn't. Real brain teaser when that happens. Usually it's not the case, but the most recent staircase I did for the Charlotte Mecklenburg Library had that as one of the things that it was kind of like a design feature of it was the guardrail didn't stop where the like the same height, like where the slope stopped on the stairs. It might just be a feature of circular staircases in general because I remember that the one for the Norfolk Southern Company here also had that same exact thing too. I'll look at that real quick. So it's kind of a weird one. It doesn't apply to this staircase, but it may apply to a future staircase that we're working on together. But I'll show you what I was talking about there with that. This is a pretty good shot of one of those. So looking at this picture here, this is the guardrail, that white stuff that's Corian, but that's our guardrail, similar to what we're drawing here. And then we have a separate handrail that sits inside the staircase. Well, the handrail on this staircase does level out with the landing, like it follows the slope of the stairs, but the guardrail does not, which makes things really weird because you can see like as it's going up the staircase, the height of this appears like it's changing. because it's not the same as it's going up. It's constantly growing or shrinking, which is really weird, kind of goofy. But if you look at it from the outside of the staircase, it makes it visually more appealing because everything follows that same slope all the way from top to bottom. But I think for safety standards, your handrail actually does need to follow your staircase, because you wouldn't want to be going up the stairs and all of a sudden your arm's like up here holding the handrail, because you don't want that. So anyway, yeah, I think for like safety standards, your handrail does need to follow the slope of the stairs, but your guardrail can be free flowing, as in like it can follow the slope of the stair, but it could also be whatever it needs to be to whatever they'd like it to be. There's no rule per se with that. So anyway, I just wanted to show you that because that does happen occasionally. Most times with just like squared straight runs of stairs, you don't really see that, but it is possible that it could happen to you. So just heads up. Let's go back to what we're dealing with here. We're going to take the handrail and we're going to make a copy of it. I'm going to lay that copy right over top of where we're working right now. So I have two stacked on top of each other right there. I'm going to take the one that we just created and use that align command. Actually, I don't even really need to use the align command. What I can do is I can just use move, because the slope of the stair is the same down here as it is up here, because we still have the same rise and the same run for each tread. So what I'm going to do, instead of using the align command, I'm just going to use move, selecting the top point of this red line, going back to down here, and I'm going to select the top point of that red line. And then if I look at it from the exact side view of my view cube, those red lines should be touching the top of that railing, which is exactly what we want to see. You see that here as well. And then when you get to the middle, we have to figure out, okay, so now I'm here, I need to level this out and then fillet it. So, or not fillet it, we need to level it out, sort of give it a miter here, give it a miter here. And so this guardrail goes up, it stops, goes straight across, and then miters back up towards the top of the staircase. So that's why I left this copy over here, because I'm going to use that to be able to pull this off. I'm going to use the move command. I'm going to take the top corner of this guardrail. I'm going to drop it right there for right now. Okay, and that should be the correct height, but we can double check. Let's do a DI distance check on this and we'll see what we're dealing with. So from the top of that handrail to the top of our tread, the top of our landing here, does read to be 42.5 inches tall. And that should remain the same all the way through the entirety of the landing. So again, at the back of the landing, it's still at 42.5 inches tall in the Z direction. So we are good on that. And just like before, we need to get this centered over those posts. So we're going to take the distance check again. We're going to go from center of guardrail to center of post. And that Y direction is 3.1, just like earlier. So we're going to use the move command now and pull our direction towards the Y coordinates at 3.1 towards the staircase. Okay. And then a lot like before, I also want to make sure that this is overhanging a fair amount. So that way these crisscross areas that we're going to slice do have enough to be able to remove without actually accidentally deleting anything we didn't mean to. So, morning. All right. All right. Now, we are going to slice all of these. All right, I'm going to leave these ones alone. I will be slicing all of these 4 posts. That way they butt right into the bottom of that handrail. Oops, what did I do? I broke it. I'm going to slice all of that. Why is it not letting me slice it? What is wrong? Oh, they're blocks. still. Oh, yeah, that's right. I forgot. I even mentioned that earlier that we were going to have to explode these. Gosh darn it. Like, it should let me slice them. They're 3D solids. They're not like they're mesh. All right. 3-point slice. We're going to go from here to there. And then I'm going to use this base point here too. So what I'm doing is drawing a plane that cuts right through at the bottom of that handrail or guardrail. Keep calling it that. All right. I'm going to delete these little pieces that are left over. We don't need them. They're gone. They're done. We're done with those. Okay, so we're starting to get somewhere that looks a little bit more cleaner like it's supposed to. We'll slice these ones to be at the bottom of that handrail. Just like this. I'm using 3-point slice again, using a point in the Y direction and the X direction to chop it right through there. Go through here. Get rid of, oh, see, I didn't explode that one too. Geez, I am not on top of my game today. All right. I'm gonna do that one more time. Okay. Then, these are already exploded, right? Yes, they are. Not these ones, though. So these need to be exploded still. No big deal. All right. We are going to slice all of these, aside from the top one. Tina's asking if you started the dishwasher. I don't think you did, right? That's coming out of your paycheck. I'm just kidding, dude. Oh,
While Cody starts the dishwasher, can I take a quick bathroom break as well?
yeah, you're good. I need a little second anyway to refill my drink. I'm gonna finish this
Cool.
monster and get some more water.
I also need more water, so that's good timing.
Mm-hmm.
I'll be right back.
Yeah. All right. espresso. I don't know how they make that though. Yeah, it's probably like antifreeze mixed with sugar. Yeah. Hashtag tea proudly because flavor matters. This one doesn't have any motivational quotes on it. It's kind of disappointing. All right. What were we doing? Oh yeah, we were
You
gonna
have to
You
be
don't
your
need
own motivational
motivation.
quote.
be motivational. That would be actually kind of goofy if they did that. I'm 3-point slicing this, but don't mind me. All right. Go on and get out of here. All these shenanigans. Oh, wait, I can't delete that one. All right. Now is where we get into your guys' favorite, the interfere command. What? Interfere. All right, here we go.
There's no reason to fear. You have a monster and tea by your side.
Yeah. This is a judgment-free zone, Cody. If you keep it up, I'm gonna have to ask you to leave.
Who's judging? There's no judgment here.
I'm just kidding. All right.
Wasn't there a commercial about that very thing where they were saying this is a judgment-free zone?
I don't know. I think it
feel
was
like
for
there
Planet
was.
Fitness or something.
Oh yeah, that's what it was. I've heard they even have an actual physical button you can go up and push if someone's judging you.
No way. Okay. Anyways.
We gotta quit getting sidetracked. I'm not only
All good.
judging, I'm distracting too. I'll be quiet now.
Okay. Well, what I'm doing isn't all that exciting anyway, but I'm using the 3-point slice with that interference object to be able to cut these down right at that miter. So I got that perfect miter between the two parts. Erase the excess part and the little interference part. Cool. So yeah, we got a little bit of cleanup work down here, a little bit of cleanup work up here, but the posts and the guardrail are all there. All right, so let's take a look at what is happening when you get to the top of that staircase and try to figure out if I really want to draw all this in or if I just want to stop it here and say that it continues onward. Okay. Well, oh my gosh. Okay. Well, it flattens out and then it carries through. So I think first things first, I need to flatten our handrail out where it gets to be that 42.5 inches from the floor to the top. We're going to do a miter there and flatten the hand or the guardrail out at that point. Then you get to the bottom down here where the planter and the actual 19th floor sit. And it looks like it does carry all the way through. And what probably happens here, and we can check it if we'd like, is probably miters down at the floor as soon as this hits 42.5 inches here. So let's check it and make sure. All right, from there to the floor. Actually, that's not 42.5, so that's a little weird, but I think I know the reason why. It's probably because this has to be 12 inches out from there to there. So I guess that's going to be our determining factor. We're going to extend that handrail so at the center of it is extending past our staircase 12 inches, and then we're going to chop it off and miter it down to the floor. Actually, that's not even, sorry, that's different. That's the actual handrail. We haven't gotten that far yet. This here is 5 inches out. Okay, let's just start there. So check that. We are at 5 inches there. And then going back to their model, is that where it stops right at the edge of that post, actually. That's convenient. Okay, that's easy. That is super easy. So we're gonna slice this right through here. Chop that off. That part's done. Then we gotta come back up here and we gotta figure this part out. So right now what I can do, I can copy this flat portion of the handrail. It's already got that miter in it. I'm gonna use the red line as my base point. So that way when I come up here, I just paste it right where that red line stops. And then I need to then just chop off this part. Just like that with the 3-point slice, just go boop, 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 and then delete that part. Then of course this post is a little tall, but we did that intentionally, knowing for a fact we'd be coming back to adjust the height there. So again, 3-point slice, I'm using that to chop that there. Okay, so we're getting there. We are getting there, okay? Let's check to see how far this extends out past the staircase, and then I'll decide later if we want to draw all these posts into, or if we just want to leave it where it stops right here, because that doesn't really matter much to us anyway. All this here is all flooring by somebody else up above on the actual floor. So let's see, from there to the edge, we are dealing with 12.1. Check this one too and make sure that is the same. Yep, it is 12.1. Okay, so going back to our model, let's make sure that we are drawing this handrail so it sticks out to 12.1 inches from the staircase itself. Just like that. Boom, handrail. Donezo. All right. And then again, if you want to just double check it, since we still have those red lines in there, these points should be touching the top of our handrail or guardrail, just like what we have drawn here. Once those are done, really, I don't need those red lines anymore. Well, maybe I'll leave them in there for right now because I'm going to use them up here too for when we get to that guardrail. So I'll leave them alone for right now. But I could delete them at this point and that would be perfectly fine. All right. Decisions. So at this point, we could drop in the 2x1 by 1/8 inch thick handrail tube. Then there's these brackets here, which I mean, I'm not really overly concerned about showing those. We could if we have time, but I want to at least show the handrail anyway. So do that. Morning. So 2x1 by 1/8 inch thick. So let's go here. We'll draw that in some random length. 200 inches will be fine. We'll go 2 inches wide and 1 inch thick. Okay. Now I realize that these do have filleted corners, but I'm going to leave them alone for the purposes of making this easier for us to be able to locate this handrail. And we're going to use the shell command next. We are going to shell this out, remove the front face and the back face of the tube, like that. And then we need to set our offset distance or the thickness of that material to be that 1/8 or 0.125. Here we go. Set that to be by others. Okay, and then similar to what we did before, we need to get these, just like the other guardrail, we need to set these in place. So what we need to do with that is we need to know, one, how high up off the floor or the front of our nosing this handrail sits, which is a perfect 36 inches. Nice even number to deal with. And then in between the post and the handrail, there is an 1.5 inch gap, which is also another industry standard. You'll see that a lot on staircases. It's just the amount of clearance space required to be able to reach your hand around that handrail if you were going to use it. So that 1.5 inch is pretty common to see. Okay. So before we move on, let's go ahead and make a copy of what we've got. I'm going to save here as well, just like we talked about yesterday. I want to make sure that I'm saving as often as I remember to. That way I don't lose anything. Especially being that I'm in Georgia and there's a thunderstorm, it looks like it's pretty good chance that the lights might flicker and I might lose some work. So I'm going to make sure I save it, make sure I don't do that. Unable to save drawing. Oh my gosh. What happened? Why? It must have been auto-saving as I was saving. That's super weird. Here, I'm going to save it as a version 1.1. That's giving me some problems there. I don't know what's going on. All right. Anyways, so I made a copy of the handrail, and we're going to use the align command next to get this lined up with the slope of our stairs. So what I want to do is this time I'm not going to use the red line method. What I'm going to do is go from using the align command starting here as my first source point. I'm going to use that. Use the front of my tread as my destination point. And then I'm going to do the opposite here. I'm going to go this end as my source point and this end as my destination point. So what I'm doing here is I'm making that making the handrail all line up with the front of the treads. It's really important because what we're going to do with that is we're going to, well, I'm going to move this down a step to not changing the slope, but I want to make a little bit more of an overhang here. It's really important because now we can set the height, because right now it's at 0. The handrail is perfectly at 0, so we're going to go up 36 inches here to match that height provided here. And then we need to find out how to set this handrail so that way it's in the right location in the Y direction now. So I'm going to isolate only these parts so we can see the guardrail, the posts, and the handrail that we're currently working on. All right. And it looks like based on this, if we were to measure from the inside edge of our post to the inside edge of our handrail, that should be a total of 1.5 inches. So we're going to do a DI distance check. And we're going to go from the inside of our post to technically the inside of our handrail, even though it's not in the right spot. And that Y direction is what we're paying attention to here. So right now it's calling that to be 4.85. So we're going to do that 4.85 plus we need to add on 1.5 or 1.5. So that way we have the total distance this needs to move from there to touching the vertical post, and then we need to add on that 1.5 inches, making this a total of 6.35. And we will check it, like I said, once again, just to make sure. So from the inside is in the Y direction, down here is 1.5. So kind of see that there. Just to make sure it's lined up where it needs to be. And then if I unhide what I have right now, I can also check to see potentially, well, actually it's not going to let me do it because there's no grip point to snap to. I was going to try to see if I could like snap to here and make sure it's 36, but we should be okay with what we've got. So like we did before too, I'm going to copy this down. I can use a base point like the front of my tread to snap it to the front of the tread here, which would give me that downward angle going this way. And again, if I was able to measure it, it would still be at 36 inches from the floor to the top of that handrail because I already had that set in stone for the railing up here. So we've got those handrails kind of sketched in where they need to be. And we got that flat one, of course, that we also have to add in as well. So I'm going to use the move command and I'm going to line this up using the top corner of that handrail. Place it right there. So that way, right now the height is at 0 inches at the finished floor or 0 inches at the landing. We're going to go up 36 inches in the Z direction here. And then we need to just make sure that we line this up with the outside edge of that handrail. So I'm just taking the outside edge of one to the outside edge of the next, which looks like 6.35 is the magic number that's going to get us to where we need to be. So Y direction 6.35. Okay. So this here is actually the legit reason why I want to make sure that we extend these past when we're going to slice. Because right now, if I was to slice this, I'm going to have a weird hole here that I don't want to have showing. So what I'm going to do is move this handrail. And I did this earlier a couple times, but what I'm doing is I'm going to move it using the top corner of one tread and match the top corner of the tread below, which will shift that handrail down, but it's going to keep it at the same height from the tread. So it's not going to change the slope. It's not going to change the height, but it will shift that down at the same angle, just so it intersects this a little bit better. All right, let's get to interfering. Isolate just those parts. Use the interfere command. Using that, hit enter, that, hit enter. Come on, and we'll do that over here as well. Interfere, boom, boom, and uncheck that delete objects because we want to make sure that that sticks around. Then we're going to slice this using a 3-point slice right at that diamond shape like we did when we were doing those faceted panels. Just kind of matching that. We're going to delete anything that is no longer needed and then the little interference object. We'll do that same thing here, 3-point slice this. Oops, I'm going to grab both parts. 3-point slice, and then we're tracing over that narrower part of the diamond shape there, just like that. Just like, oh, nope, not that. Like that. And unhide everything, bring it all back. Okay, so now that handrail is in line where it needs to be. Kind of see it a little better. Maybe things are a little goofy. I don't know if that's just because of how all the different objects I have in there right now. But you can kind of see it there. Just like that. Okay, and then of course, just like before, we're going to clean up the top and the lower portion of that handrail. This lower portion does that little number where it goes 12 inches out, and then it returns down towards the floor. We're going to do that right here. Nope, I actually do need to slice it right there. I was thinking in my head, like maybe that's not right, but we do need to slice it there, which is 12 inches out from there to there. Okay. Then we got to return it down to the floor. So I'm going to take one of the handrail tubes from up here, copy it over to the side. 3D rotate this one. So that way we're using the Y direction to flip it so it's standing up vertically. We're going to move this using any of these corners. And we're going to line it up with the corners of our tube here. All right. So we can do a 3-point slice at the floor. like that. And then we can do an interference object here to be able to slice these objects. Hey, Mark, what's up? This is a staircase for Bradley Law. These guys are learning stairs today and yesterday too. Yeah, what's up? They want that to cap off. Oh, that's Tambor. That's a good question. Can we do anything like a dado block to the back of it or anything like that? Yeah. I don't know what to say about that. We'll have to get the PM involved because that's how the architect has it drawn. And I don't know if we are able to change it aesthetically, but I was thinking if we could do like a dado block and glue it or something. Yeah. Well, that's on a rounded column, isn't it? Oh, that's in the hallway. I was thinking that was we were looking at the column detail. Yeah, I'm not 100% sure what we can do with that. Do you have any ideas other than like an angle? Like I said, like I can get the PM involved too, but that's exactly how it's drawn. All right. All right. Let's keep on moving. We got this at 17 inches wide where it levels out. So when you get to that point, see, there we go. Sorry, there we go. All right, and I'm gonna take this. Actually, I probably shouldn't have sliced that yet. Whoops. All right. Well, hold on. Maybe I need to because I need to have a solid point that's 36 inches up. All right, I can work with that. And then we'll use the align command to align this tube to there. All right. And then what I'm going to do is line this up to there and miter this together. So I need to extend this out a little bit, looks like, because I know that this is 17 inches past. Well, let's check and see. 17 inches past according to that. All right, so that's where it's going to stop. Okay, and it looks like it does return back down to the floor here too, which I actually didn't even notice that. So we're going to have another one of those details there, which is kind of cool. Oops. And I'm trying to do the interfere right here and right here. Oh, I see why it's not working. It's because I the dum-dum and I sliced that, so I'm grabbing a part that really doesn't even exist here in this case. So, all righty, let's slice these together using our 3-point slice right here. All right. Here we go. Flip this so it's vertical. Ha ha ha. Here we go. There we go. And what I'm doing right now is I'm using the press pull command with the control key to be able to, this is a cut at an angle. It's hard to see, but if you look at it from the side, you can definitely tell. So what I'm trying to do is I'm actually trying to extend this down a little bit past the floor line because I'm going to slice it so it's dying right into the floor like the other handrail that we just drew a minute ago. So this is the top of the finished floor on level 20. And so I'm going to use that as my slicing plane. And there we go. Cool. How about that? Okay, so we got our handrail drawn in, got our guardrail drawn in. We can draw in these little steel cables still. We haven't done that yet. Real simple, nothing really to it. The only thing we could possibly do here is we could add in the little brackets that go along with the handrail, but I'm gonna wait until we're done with everything to add those in if we do that. So let's go ahead and add the steel cables in next. All right, and they have a diagram up here that tells you about roughly where those cables reside. They have them at 3.5 inches apart, and doesn't tell you where they start or stop, but it looks like they're equally spaced from what I can see here, from the top and the bottom of that tube. And it does say that they're 3/16 diameter stainless steel cable. So what we can do with that is, all right. What we can do with that is I'm going to isolate a crap ton of posts. That is a real measuring unit or unit of measurement. I'm going to isolate all these posts, and then we're going to go ahead and draw in those stainless steel cables. But I'm trying to avoid having to, I'm trying to avoid having all this extra geometry in there because it's starting to get a little spaghetti mess in there. So we're just isolating the parts that we need. We don't want to draw in or have to work around a bunch of other objects if we can avoid it. So stainless steel cables, kind of what I'm thinking we can do is we know that they're 3.5 inches apart and they are 3/16 diameter. So kind of what I'm thinking we can do is in order for me to, I'm going to use the loft command because I think it's something that would be kind of cool for you guys to get to play around with a little bit. We're not going to use it for its completely intended purpose, but um, but because loft can do a crazy amount of things here. Um, All right. Sorry. I had to respond to throughout the whole training session, I always get again, unit of measurement, a crap ton of emails and Teams messages. So I have to get caught up with those periodically throughout the day. Otherwise, I'm going to get buried at the end of the day. So every time I see a couple of them show up, I try to get caught up and then try to jump back in here. So that way I'm not holding you guys up too much, but I'm also not holding up people outside of this training chat too. Anyways, so my plan is here with these steel cables is that we did use this command earlier. It was yesterday, I believe. In your 3D modeling toolbar, if you're down here and you go into 3D modeling, there is a command here that will allow you to adjust the plane at which AutoCAD is drawing on. So by default, your default plane that you can draw on in your 2D drawing is the XY plane. It is your top-down view. You can change that so that your X and Y are actually facing a different direction, which is useful in some cases, like what we're about to do here, because what we want to do is be able to draw on the side of one of these tubes to draw the circles for our stainless steel cables where they're going to be going through those. So what I'm going to do here is I'm going to go over to this command up here. And like we talked about yesterday, if you already have your view lined up and you want that view that you're looking at right now to be your XY or your top-down view, you can click this button. And what will happen is you'll see your view cube switch. You're now looking top-down at this, even though this is at a weird angle. This wouldn't really be what you'd want to be using for your top-down view. But just for our purposes, like if that's what I wanted, that's what I would be able to do. Now, if you want to go back to your standard top-down view, you just go over to your view cube. Underneath of that, there's a drop-down where it says WCS. That stands for World Coordinate System, and that is your standard XY sort of top-down view. If you click that, it'll reset it back to normal. Once you've done that, the other type of thing you can do, and I'll show you 3 different ways to do this. So one would be that one we just looked at. If you're already looking at what you want to be your top-down view, you just click that button and boom, you're there. If you aren't looking at that, what you can do is you can go down 3 spaces here to this one called face. And what face does is it will align your XY to whatever face you click on. So right now, like for our purposes, that would be really helpful because I can click on the outside of my post and you can see as I'm hovering my mouse around, it's changing my XY to be either the front or the side of that post. And that's where I want to be because I want to be able to sketch on one of the sides of our post here. So we'll do it that way. The other method you can do too, we talked about this one yesterday, is up here under your view cube, there's something called new UCS, and that stands for New User Coordinate System, which is essentially what we're just setting up by clicking on the face or clicking on that current view to be your top down. That's what's called a UCS. Now, you can manually set that up if you go to your view cube and you go down to this new UCS. What it will do is it allows you to move the gizmo, the little red, green, and blue, and you can click on a point, click on another point, and then as long as it doesn't fight me here, you should be able to set the side of your, there we go, the side of your post as your XY view. So you kind of use it like the align command, where you start by clicking on a base point, clicking on one direction, the X direction, and then the Y direction would be your other direction when you click your mouse. So yeah, you could use that too. I'll just leave it as it is, but what we need to do now is draw in the circles for the steel cable. So 3/16 diameter stainless steel cable, and here we go. 3/16. All right. what I'm doing here is let's count how many of these steel cables we need per post. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 steel cables. So let's go ahead and copy this circle. Whoops, I need to put my orthostat back on my F8 key. All right, so let's see, these are 3.5 in between. Then once I have the first one copied, I can use the base point of the one below to copy all of these throughout. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay. The other thing they show here too is that they do show these roughly equal from the top of the post to the bottom of the post. So we're going to try to match that here too. So to do that, we're going to use the move command, highlight all of our circles. Okay, and we're going to go shift right click mid between 2 points. All right, we're going to go between the center of the last circle and the center of the first circle that we drew. And then we're going to go shift and right click, and we're going to go from the bottom of our post to the top of our post, like that. Okay, now that we have that, what we can do is we can, let's just make sure, how far do these steel cables go? They go all the way to the landing, or do they stop? I think they actually stop. There's like a little gap here without steel cables. So our steel cables are going to go from the bottom post to the one at the top of the landing, but not the second one at the top of the landing. So let's go back to our model. Okay, and what I'm going to do is I'm going to copy, I don't know if I want to copy all of that. I think I will actually. I copy all of this down to here. All right, I'm going to 3D rotate this so it's facing the other way, or not. 180, there. All right. Then what I'm going to do with this is I'm going to move these dots. I'm going to use that mid between 2 points again, going from center of last dot to center of first dot. And I'm going to do the same up here. We'll go top of post to bottom of post, just like we did before. Okay. So this is the cool part, because I don't know that I've really walked you guys through that loft command yet. So the loft command is pretty neat. Oops. Let me go ahead and save what I got. Okay, and we'll go through some of the things you can do with the loft command, and then we'll actually use it for what we're trying to do here. So the loft command is pretty cool. It allows you to be able to go and draw something. Switch my UCS back to the WCS. It allows you to draw some pretty complicated objects. So like if you wanted to, you could draw, I don't know, for example, you could make this square turn into a circle, and then you can make it turn into a triangle or something. Let's just do that for fun. Just because. All right. So your loft command is pretty cool. Let's go ahead and start that. Oh, I could just type it in, but I was trying to figure out where it is up here. I might have just missed it. It does exist. I'm not crazy. Just not seeing it. How strange. All right, well, we're gonna just type it in then. All right, so loft is going to allow you to go from, what it's gonna ask you to do is to select objects that you're lofting and in the order that you're lofting them. what that allows you to do is like actually make some pretty cool shapes. So like I'm actually transitioning that square that we drew initially to a circle here, which then transitions to a triangle, which is kind of cool. You can do some pretty neat stuff with it. You can do other things with it too, but what we're going to use it for today is we're going to be lofting the circle that we drew at the top with the circle that we drew over here. And you could potentially, I wonder if you could do it with all of them at the same time. We'll try it and see. Yeah, it's not going to let me do that. That's okay. But the thing is, you can do these all just selecting the first one, selecting the second one, and then starting a new loft command. And it will generate the shape of that steel cable that we're talking about drawing without you having to do any alignments, without you having to do any slices or anything like that. As long as those circles are in their correct locations, then this should work just fine. So that's just another way you can go around doing some things in CAD. All right. There we go. Done lofting. So it's a really quick way to be able to draw all these in without having to make a bunch of cylinders, slice them, copy them, rotate them, all that. I'll put these on the by others layer again. And then I think loft actually works a lot like extrude, where it will delete the original object, like that little 2D circle we drew. So we don't have to worry about, oh, we don't have to worry about that so much. I was just thinking I probably should have made a copy of that because now I don't have the original anymore. So we'll live. We'll be okay. All right. Anyways, so now let's go on to the next part. Next part's pretty easy. This one we could do it the other way. We can just do a bunch of cylinders if you guys want to see it that way too. So let's see. These cylinders should be diameter, so D, and they are 3/16, so 0.1875. And we can set it to be some arbitrary length, as long as it's long enough to go through the steel posts. We'll do a 3D rotate on them, like so. And then we need to line these up. So I'm using the move command to paste this where it's going to sit right there. At this point, I could actually take this and line it up with the side of my tube. That way I'm not having to slice 11 of these. I can just slice one or move one and be done with it. Now, just like before too, these are 3.5 inches apart. So we're going to go 3.5. And then I'm going to copy these all the way up. You could also use the array command. If you are familiar with that, you can do that too. And again, we want to make sure that we have 11 of these by the time we're done. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Cool. And then before we can call it, we got to make sure that these are centered in height. So let's do that. Highlight all of our tubes or our cylinders. And we're going to go shift right click mid between 2 points. Go from the center of that cylinder to the center of that one. Shift right click mid between 2 points. Go from the bottom of our post to the top of the post, like that. Okay, and then again, hit these all on that right layer for by others. Boom. We're starting to get there. All right. Now, trying to think if I can just copy these or if it's gonna cause an issue. Let me try it and see. We may be able to save ourselves the headache of having to redraw those if these actually work out right. Oh my gosh. I think they did. That was just a miracle. Okay. I didn't have to reloft those because I was able to just copy and paste them over because it's the same exact stairs below the landing as it is above it. So how cool is that? So we got that whole assembly drawn in and unhide everything. That is looking pretty cool. That is looking very nice. All right. So I think what I'm going to do now is we're at a good point where we're able to now mirror what we have drawn to the other half of our staircase. And I'm going to only show what's on that by others layer. To do that, you can just highlight one part that's on that layer and then go up here to your layer properties up here, and there's a little isolate command that allows you to only isolate the parts that are on the by others layer. To get it back, you just click on that sheet of paper with the arrow going the other direction, and it will bring everything back. But because all we're doing here is we're just mirroring these, I should be able to just highlight all of these parts and be real careful that we don't forget anything. I am just grabbing anything that has to do with the handrail or the guardrail at this point. We already did mirror the stringers yesterday and all these steel tubes that are attached to them. So we've already done all of that. So we don't want to mirror that again. Okay, now I need to find a midpoint here to mirror this. So I can do that. Maybe holding shift and right click would be a good place to do that again. I'm probably getting boring talking about this mid between 2 points, but I use it all the time. So if I go from the middle of that stringer to the middle of that one, and then say do not delete your source object, should leave us with the guardrail on both sides. Pretty snazzy. Bring everything back. How cool is that? Makes the staircase look dinky up top because it doesn't have any fancy decorative stuff on it, but we'll get to that one next. Fortunately for us, a lot of this can be copied from the staircase below to the one above it. The only thing that's going to be different is where the landing sits, because the landing is a different length than the landing below. So we need to be careful about that when we go to copy these up. We got to make sure that it actually matches up correctly. All right. And I suppose I can get rid of these red lines now. So I'm going to go into these blocks and delete them. You just double click on it and hit OK. And it will allow you to go into the block editor to remove those. Once you've removed that line, you just click this green checkbox up top, which will save changes to your block. And all we're doing is we're just deleting all those red lines. So I got to do it in a couple places because the tread and the baby tread are two different blocks. And that can go away too. And that can go away as well. Boom. I'm very excited about this. It's starting to come together really good. Mm-hmm. Oh. All right. Oh. Now I might need a bathroom break. Last time I just spent the break getting tea. So I'm going to take a 2-minute break here. I'll use the restroom real quick, and then I will come back and we'll finish the guardrail and handrail on the top staircase. And then we can talk about plotting staircases and what it takes to plot those, because they are a little different than some of the stuff that we've been plotting. Not a ton, but enough that I want to make sure that I can show you guys what we're doing here for that. So I'll save this here.
I'm gonna run to the bathroom as well. Take advantage of the break.
There you go. Take a quick break, and we'll be right back. Oh. All right. You guys set? Okay, cool. All right. Let's see. What were we doing? I think I was just going to copy some of this stuff up. Yeah, I think that's where I'm going to start. We'll copy the angled pieces up because they actually won't be any different than, oops, I don't know why that's there. I must have drew it in earlier as an example and forgot about it. All right. We'll copy all this angled stuff up. I'm going to start with one half of the staircase first and then copy the second half up next. Just being real careful not to shoot. I have to hide my treads. So I gotta isolate that by others layer again. I only say that because I wasn't able to get these plates below. There's no way for me to like highlight them to be able to select them. So I'm gonna copy all of this fun stuff. Trying to get it as best I can. It's kind of hard. There's a lot of stuff going on here now. But we will figure it out. Okay. I'll copy this too, but we're going to have to change the length of that. So, right. And I'm going to copy this as well. All right. Come on. Here we go. Okay, cool. Maybe I'll copy these two verticals as well. They'll have to move regardless anyway, but I'll just bring them up top with us here. Okay, so I need to find a base point that matches up with a base point up here. Because I don't have my treads, what I'm probably going to do is actually make the base point one of the corners of this vertical tube that sits below the tread. So let's just go ahead and roll with that method of thinking. We'll use this base point here to copy, and we'll paste it in the exact same base point up above. And again, I knew this was going to be an issue, so we're going to have to fix that, but we'll get to that. Actually, maybe we should just do that before we actually move on to copying the bottom part, because I think we can easily correct that here. Okay. So I guess I don't need these actually, because there is no middle post on these ones. They just have the double and the double. Okay. Well, hey, that makes our lives a little easier. So then I need to copy the double and the double from down here. Hey, all right. And as I do that, I bet you I could probably also copy all of this too. Because where that double plate sits should be the start run of the downward handrail and all that. Okay. All right. So same thing we did on this side. I'm going to find a base point that correlates to a base point down here. And so I'll probably just do the same type of thing where I use the front corner of that tube. I'm going to paste it at the front corner of the tube up here. And it looks like things are lining up all right so far, so that's good. We love to see that. And then what we're going to do is we're going to slice these so that way our handrails aren't overlapping and our guardrails aren't overlapping. So we're going to do that here. It's a little messy, but I'm going to try my best to clean this up here real quick before we move on. So using a 3-point slice because that miter is already pre-built into that handrail. I just have to correct this half of it. And then the same thing with this too. that miter is already pre-built in because we've already sliced it down below, and it's the same angle where the two parts meet. So I just need to shrink the long flat portion of it to match up with this, just like that. Okay, that goes away, that goes away. All right, and then what we're left with is we have to fix these steel cables. Grab all the steel cables that we can see. All right, and I am going to take those steel cables and we're going to slice them back to that vertical post. So back to the corner here where this post stops. We're going to do that right now. Slice that, and I'm going to tell it I want to keep this half of it like that. Kind of helps a bit. Actually, that makes it a lot easier to see. All right, through the power of slicing, we have fixed our staircase. Now let's bring back our treads and just make sure that everything looks like where it's supposed to be. Hey, that is pretty sweet. Pretty sweet. All right. So at this point, I'm going to save it again. At this point, we could throw in those brackets if we wanted to. We could see if there's anything else we need to draw in. I think there's a couple of these beams down below that I didn't put in when we did the stringers the other day. You could add those in too. I gotta figure out what those are, like what size tube steel they're using for that. We can throw those in. That sits right between these two stringers below the landings. Looks like they showed that on view 5 on page C. Maybe. Oh, they actually did. Okay. So they have these dimensioned at 10 inches tall by 6 inches wide. And it's some kind of like a welded box because really you have varying thicknesses going on here. So the side walls are 1/4 inch thick, the top and the bottom are 1/2 inch thick. So as we draw that, we're going to make sure that we draw that right. So here we go. Let's go ahead and make that shape. Man, this is going to be one cool looking staircase. I'm so excited about this. All right, so the base plate is 6 inches, but we got to take off 1/4 and 1/4, so it's going to end up being 5.5. 5.5 inches wide. And right now, I don't really care how long it is. So I'll make it 150 inches, and then we're going to make it 1/2 inch thick. So that would be this part here. We also have a top plate, which is 10 inches up from the bottom of there. Copy. Aha, there we go. And then we need to add in those 1/4 inch vertical panels that sit on the sides of the beam. So those are, all right, there. They are 0.25 thick. They're 150 inches long, just that arbitrary distance we selected earlier, and they're 10 inches tall. Arbitrary distance is literally nothing but that because we have to put these in between the stringers, and I just didn't feel like pulling a measurement on it yet. So I was like, we'll just slice it when we get to there. Okay, so it looks like these beams are centered underneath any of those steel pieces that we see below our landings. So these gray stripes that are here, that's what we're talking about. So this landing here should have 3, and this landing here is going to have 2. The landing that we're looking at in this metal shop drawing is the landing on the staircase between 20 and 21, which is why it only shows the 2. So let's go ahead and let's get this beam put where it needs to go. I'm using the move command here, and I'm just taking the midpoint of the top of the beam. And then I'm going to use, if I can get to it, Okay, I may need to do some fanciness here. All right, what I'm gonna do is I'm gonna hide all the layers except for by others, and for some reason I used existing for those plates. So I'm gonna turn the existing layer back on here. All right. Now let's try to move it and see if we can get this to work. Okay, so we will snap it to there. We're going to use the slice command, and we are going to remove any of the beam that does not fit between the stringers below the staircase, because you can see in their model that's what's going on there. Those beams only go between that stringer and that stringer there. So let's chop those back. We use a 2-point slice, and we're going to go from the inside of the stringer out like this. We're going to save this side, and we're going to do the same here, but on the opposite side. So inside of the stringer, pull the line straight back, and then select a point on this side. Okay, let's see if I can get this to work. Use the copy and then the PR. Type in that in after you type in copy, and it allows you to select the previously selected items. So then I can take these beams and I can literally just kind of copy and paste them where I need to put them, just like that. Pretty nifty. So those beams are all where they need to be. All right, what else do we need? Make sure I'm not behind on any emails real quick. Nope. Nothing I just talked about for Trist is already aware of, and no messages again. Okay, here we go. So again, I'm going to save it. I know I just did that, but I'm going to save it again. Make sure I don't lose anything that I'm trying to save. Okay, and from our side, I think the only thing left, aside from maybe putting those brackets in to hold the handrail up, which again is all somebody else's scope. So I really, if I do that, it's more of a detail thing than anything. But what I can do here is we have this this planter that we need to figure out still. Okay, and so this planter isn't drawn with any detail at the current moment. All it is a completely solid object that we just subtracted out like a piece for the planter where the plants would sit, and we subtracted out like the stair steps at the front. So nothing there has been detailed out, and we need to go through and we actually need to try our best to figure this out. So unfortunately, there's no architecturals for this planter, but I'm going to bring up some old examples of some planters that we've done and platforms so I could show you guys some of the methods that we can go about actually drawing this up. And also the other bad thing about this is I actually don't know what the material is on this planter at this time. So it makes things a little bit more difficult too, because I'm not able to accurately depict where we're going to need field joints, unfortunately. So I think what I'm going to do is try to go with the standard method of thinking that usually a field joint, you're going to have them every 4-foot by 8-foot section. Okay, so if I do that, let's first go ahead and clad this thing. Okay, so well, maybe not cladding is the right word. We could probably shell it first. And shell it so that way we have like a thickness of 3/4 of an inch for the outside perimeter of this thing, but then make the base of it open. So let's go over to shell. Let's remove the bottom face because that's going to be open. And then offset distance is going to be 0.75. I'm doing that because that's our typical thickness for most things. And if I go with that method of thinking, now what I have here is a little bit more complex. I have a a shelled model of the platform and the planter below the stairs. So I want to look at something real quick. There was this project that we used to have pretty consistently back in the day. It was for a museum here in Atlanta called High Museum, and they employed us to build. They employed us to build a lot of platforms for the art pieces in the museum. We don't see a lot of work from them anymore, and I think because the reason why is most likely that we probably weren't making a lot of money as a company building platforms for this museum. Although I used to have a lot of fun drawing them because they were really easy and quick to draw, so I could kind of race through them really fast. But I want to see if I could find some high museum pedestals or platforms so we can look at the framing on those. Maybe this one isn't a good example. There appears to be nothing in there. Okay, let me go back. Try a different high museum. Like I said, they used to employ us a lot, so there was a lot of different high museum projects in the day. Calder Picasso. I bet it's probably this one. High Museum Pedestal 6080 probably has some here. Yeah. All right. Cool. We'll look at one of these. Oh, this is okay. This is not what I'm trying to find. These are all super complicated pedestals. These are not what I was trying to find. Not trying to scare you guys off. Those are totally different. All right, let me see if I can find a different one. Maybe it's platforms. More of what I'm trying to find. Morning, Ben. Okay, drawings. Nothing in there. Hmm. It looks like Trevor just released this as an OSS page. He didn't even have us draw it. So that's not a good example either. Dang it. I'm trying to remember how far back these works. I mean, I know it's been a minute since I've drawn any of these things. Nothing. I'm striking out all over the place here, guys. This was probably before my time, so I doubt there's anything in here. Huh. All right. Well, that's okay. I was assuming I was going to be able to find something like that, but let me try something else. One more thing, and then I'll call it. Oops. Yes, I meant pedestal. No, that's that same one. That's the one we just drew together. With the faceted panels on it. Oh, that's one of Callie's drawings, but that's not a pedestal. Whoops.
I think that was for that those like file cabinet style
Yeah, it's the one that
things
had the
we
wheels
did.
on it.
Yeah, because we called those pedestals because that's I think what they called them.
Oh, you know what? That makes sense. Hey, check this one out. This is the cabinet next to your desk. I forgot I drew that. Or no, Sam drew that. I don't know why my name was on. I must have did some red lines or something to it. Those are the pedestals that are next to your desk up there. Up in Illinois land.
Let's say those looked pretty familiar.
Yeah, I know a pedestal when I see one. But I'm not seeing the ones I'm looking for here. Really unfortunate. Well, this is from the Pablo Picasso exhibit. That's okay. I can't find exactly what I'm looking for, but I can kind of use Jake. This is Jake Stocker's drawing that he had done for listing probably quite a few years ago. But he's got an assembly here, which you can kind of see. So this is like the base below. He's got some vertical die walls in there, just standard vertical ribs that go all the way around, just like that. Then sitting on top of that die wall, or that series of die walls, he has something that looks like a ladder frame or sub base. You can, it is referred to as kind of both of those things a lot of times. And when you do hear that word, that's kind of what we're talking about. It's pretty much just a die wall that's flipped on its side. We used to do this a lot with pedestals if they were taller, because you could save a little bit of material doing it this way. And it's kind of like how you frame a house a little bit, like having joists below your flooring. So we used to kind of do this when it came to doing pedestals, but our pedestal is relatively small, so we may not even need to do something like this. But I wanted to bring it up because it is something that is common to see whenever you have a really tall pedestal. Unfortunately for us, so like in our case, what we're probably going to do is die wall framing through this area, but we're probably not going to need to do like that ladder framing. Hold on, maybe I'm wrong. Maybe we do. How tall is this? If I go from here to the floor, what are we dealing with? Just shy of 19 3/4. Oh, that makes sense because the treads were 6 9/16 tall. So that's why we have a weird number. Okay, I'm gonna say we probably are gonna do that sort of method of framing here, where we do the vertical die walls in 4x8 rectangles, and then we do the tipped over ladder frame die walls on top. So what we can do is maybe what might be useful for us is if we had, like if I take a flat shot of the bottom of this planter, yeah, flat shot A. What I'm going to do is turn off the obscured lines, set everything to by layer. I'm going to make a flat shot of this so that way we have a template to work off of. I'm going to paste it off to the side. Okay, just like that. Okay. Oh, shoot, I lost it. I lost it. I don't know where it went. Hold on, it's probably on layer 0. Of course it is. AutoCAD just loves layer 0. Okay. So, all right. Anyways, so what I'm planning on doing with this is I'm going to use this as a template to draw our die walls in. So kind of like what we talked about, we do know that standard die walls or standard material sheet sizes are roughly available in 4x8. Because I don't really know what the material is that we're using here, I'm going to draw in a 4x8 or a 48x96 rectangle. And I'm going to place that here over top of our planter. I'm going to use this to actually start to draw in sets of die wall frames. So what I would like to do is kind of copy this through. So these blue lines are kind of representing where I'm breaking the material at. I'm left with a goofy little one at the end. So maybe what I should probably do instead of using a standard 4x8, maybe I'll just go back and I'll probably go through here and use an array command to make sure that I'm actually able to get these in sheets that are less than 4x8, but not end up with some weird little leftover fall off piece at the end. So we'll do the array path command. We're going to select that one vertical line here, select our path, and then I'm going to break this up so that my sheets are 48 inches wide or less. So if I put in 7 joints like that, then I should be able to pull that off no problem. So right now I'm at 41.416, repeating, sort of like going on in between each seam in our platform. Okay, so now that I have these guidelines put in, I'm gonna put them on layer 0 too, that way they stand out. It's probably very hard to see this on my shared screen here. Okay, so now that I have these, what I'm gonna do is I'm gonna draw in a die wall, and I can either draw it in manually or I can draw it in using the die wall block. It doesn't really matter. Either way would be perfectly fine. But what I would like to do is I want to make sure that I have nailers on the outside to give whatever this panel is something to attach to. The inside can be bare bones. It doesn't need any hang cleat. It doesn't need any sort of nailers or anything like that, because it's inside of the platform, and there's nothing there that really has to be attached to anything. It's just hollowed out on the inside. So I'm going to grab in the, let's see, I need the horizontal section, and I want the one that says blank and nailer. So blank on one side, nailer on the other. Wait for it to load. This block is a little bit complicated, so it's going to take it a second. All right. Drop it in here, and then I got to go hunting it down. All right. So the nailers are all on the outside. You can see that plywood strip right there. What I would like to do then with that is I'm going to locate this here by placing it right at the corner of my rectangle. And then I'm going to take this and stretch it out so it's going that direction. Probably better that we did use the block, because it's going to save us a lot more time than trying to draw this in by hand, because it automatically makes your studs no more than 16 inches on center, which is our standard for that sort of deal. When you do get to a corner, like right now I'm looking at this corner here, when you get to a corner like this, actually we won't, we can leave the nailers on, no big deal. Anyways, the reason I was bringing this corner up is because we like to put miters on everything as drafters because it looks prettier. But this is inside of your platform, and so you're not going to need to worry about mitering this die wall to this die wall. Really, whenever you're dealing with die walls, what we usually will do is we'll actually butt them together. So how I have this die wall just stopping at the face of this die wall is how we would typically see that. All right, and so really, now that I have this, that's kind of the template for our standard platform. We're going to have one custom one over here below this step. And we're going to have to do some custom finagling around the planter, because there is going to be a need to have to build around this. Maybe what we'll do is we'll just copy this over. I'll carry this through, but aha. SOPs, standard of procedures. Sometimes you just got to put your foot down. Hey, I mean, I'm going to get a refill on my tea real quick, but I'll be right back. I have a shirt you can borrow. It's got a picture of a flamingo on it, and it says, "Don't make me put both my feet down," or something like that. Don't we just have a standard shelf that the brackets go on? Do we need to start labeling them? I mean, I hate to do that, but we might have to. And they used them for a different thing because they had this thing that had to get done really quick, and they're like, "Oh, we have these. I'm just going to take them." So what we need, and this is going to involve Sean most likely, is we need a database of what hardware we have out there, and if people decide they're going to take a piece of hardware, they need to sign off that they took it, so that way we know that we don't have as many other. Oh, well, they're going to have to. If they don't, then you're going to have to reprimand them somehow. You like on the form, as you give them the direction, be like, you have to tell them or ask them what their favorite candy bar is, and if they mess up, then you have to just stop putting those out. Oh yeah, I'm telling you, these boys would get really upset. All right, sorry. She was dealing with an issue where you guys have that in Love's Park all the time, where people will take something from the shop and use it like a bracket. For say, that's what we were talking about, is like if somebody takes a bracket off of a shelf in the shop and they don't tell anybody that they took it, then the shop doesn't realize they're missing a bracket. So when they actually need it, they don't have it and they have to order a new one. So I was like trying to give her some ideas. I'm like, well, you could make a sign up thing that says like if somebody takes one, that they like signed it out, like they took it out of our library. But she's totally right. Nobody would ever follow through with that. Anyways, all right. So we kind of made a layout of all of our die walls, except for the little baby one here underneath the stair. But I'm going to deal with that separately. I do need to build die walls around this planter too. So what I have here probably isn't completely accurate. Actually, I'm going to fix that here real quick. We'll go ahead and adjust this to, I think, what it's going to look like. I have a little baby die wall there to bridge those. Same deal here. And same deal here. If I can get it to snap. Man, all right. Okay, and then we're going to copy all of these. We're going to copy those down here. And it's getting some really complicated framework in this thing, but it's actually, these are so small, I don't think we even need them. Let's just scrap them. I got a better idea. It's kind of going to be a waste of our shop's time to have to build that. All right. Then what I'm going to do instead is I'm going to take this die wall, flip it around. So it's facing that way. And I'm going to line it up here so the nailers are touching the. Would we want to put them on the inside or the outside? Definitely the inside. So they want to live here, which should be right. Right. I think I actually, oh no, that should be right. Sorry, that is right. Just getting myself confused. All right, so I'm building a perimeter die wall around the planter itself too, because we need something to attach whatever those panels are going to be inside of that planter. And so if we were to think about it that way, we're going to just do a quick little perimeter die wall that just goes all the way around the outside of the planter. Boop, boop, boop. But I'm going to break it up intentionally here too, because I want it to have joints that are in those 4x8 squares, or roughly 4x8 squares, like we've been doing. Yay. There we go. All right, now we're getting somewhere. Now we are getting somewhere. We just have a whole series of die walls here. And then this one is a little shorter, so we got to bring it in like that. And I'm going to mirror these. And then we'll actually 3D model these die walls too to make it actually like clear as to what the heck I'm doing here, because it probably just looks like a jumbled mess right now. Okay, so we've got die walls going around these field joints all the way around this whole thing pretty much. And then we have a die wall wrapping around the outside of that planter. Okay, when we get to the step, we're going to handle that separately. But for right now, what we can do is we can roll with what we do have. And the other thing we need to know, again, I need to write this down because I forgot it already, is what the height is from the underside of the finish face to the floor. Make sure that's right. There. Z direction is 12.375. 12.375. Okay. That is the inside height from underside of finished panel to floor. So when I go back over here to our die walls, these are all 4-inch wide die walls, I think, right? Yeah. So what I'm going to do is I'm going to make these, well, they're ultimately going to have to be 12 3/8 or 12.375 inches tall. But I'm going to subtract off 4 inches from that. So these die walls are only going to be 8.375 tall. They're going to be little baby die walls here. All right. So let's start by, oh gosh. I guess we could start by pulling the ribs up. And we said that was going to be 8.375 for the height of the vertical die wall. 8.375. Okay. Yeah, I could pull that up too. They are going to be rabbited, but just check something. These are 4 inches right now. Is that's right? No, not quite. Oh, that's right, because again, these are rabbited blocks on the outside. So let's pull that out. So that now it should be 4 inches wide in total. Got it. Okay. So these are our ribs. And I'm going to copy these throughout. So every time a plywood rib occurs, I need to copy it here. I'm using that die wall block. The horizontal die wall block is my template for that. So that way it makes it easier. I don't have to do the math. I don't have to do any arrays to be able to get my ribs to be equally spaced. And 16.
Is that block in, oh, sorry.
Oh, you're good.
Is that block in the folder? I was looking through my die wall tool palette and I'm not seeing like a horizontal one.
Oh, shoot.
So I was just curious. I might just need to update them, but I just have that top part.
Here, let me, before I do, I'm going to save this to make sure that that tool palette is in that folder. I think it is. You might just have to update it because I think we added those after the fact, like they got added in later. sorry, that was a while back, but that might help you though too. So where is that? It's drywall sections. Drywall sections. There they are. Export. I'm going to save them in that tool palettes folder just in case they aren't already in there.
Sweet. Cool.
Yeah.
Awesome.
I
Thank
do
you.
still, yeah, no problem. I do still owe you guys a video on how to do all that too, because there are some things that I was adding to the drywall, or sorry, to the tool palettes, but I'm not quite done with it yet. So I was gonna wait till we had a little bit more to go on there. But I added these in. I don't know if I showed you guys those or not. Little chairs. Maybe, maybe not. They're just little things you can drop into your CAD file. Like if you were doing an axial view and you wanted to show a chair, like things like that, you can like say I want it to be more of an office chair, so I can switch it to a different chair type, and then it's really laggy. I might have to delete some of the chairs that are in there. Hopefully I just didn't break AutoCAD. That'd really stink. Here, let me hit the escape key a couple times and we'll just give it a second to do its business. But yeah, if you want to sync that dive wall sections, you can. Should be in there now. And then oh, see, it just, I don't know why it took so long. Anyway, should be in there now though. So if you want it for anything, you can use it there. I think those might also be in the most current blocks file too, but it's easier to use them through the tool palette. So if you want to sync that, you can. All right. I wish it just automatically updated. That would be a lot nicer, but it's better than using the tool palette anyway, regardless. But all right, cool. We are sorry, the blocks file, not the tool palette. All right, we got our ribs. Pachow. I'm gonna put them on the actual ribs layer. Go. Okay. And then underneath of those ribs, we should have a base plate. So I'm going to draw that in. Bada bada bum bum bum. 0.75. Right. Could do a locator plate too, honestly, but our ribs are going to be so tiny it might make it like not worth it, but we'll do it anyway just for fun. All right. So we got our locator plate here. Got our base plate here. And come on, our top plate here. I think I did something wrong with that because it turned white. That is not right. Base plate. Okay. All right. If we want to draw this accurately, our top plate and our base plate are going to receive rabbits in there. Not like the Easter Bunny rabbit. They're going to be like the millwork rabbit. So looking back at like, did I send you guys a picture of die walls? There was like a die wall that I had found in the shop at some point. Oh, that's a different
I
drafting
think
training.
so. I think it was probably a week or two ago, maybe.
Oh yeah, here it is.
Yeah.
This is a really, really good example of just a small die wall, similar to what we're building here. But the reason I wanted to bring it up is because those rabbits are there. They're only a 1/4 inch deep, but they get routed into the base plate and they get routed into the top plate. So that way those ribs have like a little puzzle piece that interlocks. So when they go to assemble it, it makes it a lot easier and faster to assemble it. So we're going to put those in just to be accurate with our drawing. Figured I'd bring that up because that's in there. I have to hang on to those pictures because those are really, really good examples of how that's supposed to look. All right. Actually, I'll just put this over here for now because we don't even need the metal shop drawings for the moment. All right. So because we're building our die walls similar to this, and that is how we would typically build them. see. I'm gonna send Cody something real quick. Not you, Cody. Cody in Lost Spark. He had a question for me about he wanted the life safety plan for the Austell office, and I gotta figure out where that is and send it to him. Let's see. Drawings.